Okay. Yeah, it's okay. Everybody, good. So we'll just start, I think. Yeah, so welcome to this workshop. And I hope you have been prepared and have checked this. I have posted this last week about what you should install on your computer if you want to follow along. So who have done it? Can be honest. Who haven't done it? You haven't done it? How many people still? Okay, don't worry. Then you can try doing it now if the internet is good enough for you to download it. So the thing is, because today we'll be writing some Rust code. So Rust is different from Python. So we definitely need something else to make Rust work. So that's why we need to set it up. So if you, I never showed you the link to this repo. So where should I put it? Let me see. Give me 1 sec. Just sit down. Okay. So if you go to, I'll just put it at the README for now. Sorry, give me 1 second. I'm going all the back to the top. So, right. So, okay, I'll put it here. So this is the link. If you go to the link, you would go to the page I just showed you on GitHub. So on that page, there's actually everything you need. So there's a lot of things that like information, because we only have 1.5 hours. This workshop, last time I did it, is 3 hours. So we may have to skip a lot of things and we won't be able to finish everything in this page. So there's a chance that you could, maybe, you want to read some more, understand why. You will find all those links, the information there. Also, you would be able to continue to work on it, to learn more if you want to. So that's why this link is super important. So if you forget everything today, but you just need to remember this link, okay? So I will give you a few seconds to remember the link. Okay? So now you're here. So if you want to follow along, you have to install Rust. And also, since we are writing Rust for Python, we want to try it out in Python as well. So we also need Python. I would recommend having using 3.12. I know 3.13 is very fresh and new and very exciting to use, but to be safe, like there's still a lot of things we haven't tested out. So like using 3.12 is more stable. We're also using a older version of Maturin and Pile3, but I have listed it there, so I will show it to you. So we would try to use the same version together today, because Pile3 is a very, very young project. So every day there's like things that has been adding and like make it better. So for the smoothness of this workshop, we just try to use the same version together. So to avoid some kind of things that, the version are different and they should be done differently, and we won't dive into that too much today. Using virtual environment is very important. So what we will be doing today is that we would, write some Rust code, and it will be compiled into a Python library. And we want to install that Python library to test it out. So that would be installed in your virtual environment. So using that is highly recommended. So for those of you who is using Windows, unfortunately for you, it's quite complicated because Windows is very different from Mac and Linux. I am not a Windows user, but I have asked the Windows user. So this is what you have to do to make Rust work for you. So you need to have C++ build tool, because when things got compiled, C++ is most C and C++ most of the time is needed. Also that the area file that are needed. I don't quite sure about the detail. Again, I'm not a Windows user. This is the information I get from someone else who is an expert. So hope that those information can help you out. Okay. So If you haven't done it, try to do it like now. So hopefully like later you can catch up. But if not, don't worry too much. Again, like you have everything you need here with you. You can, try it at home if you can't follow today. So after you have all these like things that you set up, first thing you do is, sorry, any questions? You can stop me at any time if you have questions, okay? So first of all, like after you have your Python, your Rust, everything ready, first of all, create a new virtual environment. I'm using Pycon here, but you feel free to use UV or whatever you like that you're more comfortable with. And then go into the environment itself and then install Marturin. So Marturin is actually a Python library. That's why you can pip install it. But it's also a very important tool that will be used to compile our Rust code. It will actually, under the hood, it will call the Rust compiler, and it will, magically convert your Rust code into a Python library. Let's put it this way. So Marturin is super important. That's most of the magic that happens there. So far, so good. So next, we would be, using Marturin. So for those of you who have used other libraries like Django, sometimes there's like a magic command to help you start the project. So you have, the project structure to start with. So you can do that. So the magic command is Marturin init. So what it does is here is like create a directory, go to the directory, and then use Marturin init to create your project structure. So after that, you should see something similar to what I have here. Let me see, how can I make it bigger? So unfortunately, the left-hand side, the project structure, like this, I don't know how to show what is directly to you. But you should have a cargo toml file and a pyproject.toml file. So there's two toml files here. After you have started, of course, you also have a directory called src, which is normally the name used for storing the source code. So inside there's the lib.rs. So instead of .py for Python script, .rs is for Rust script. So you see, this is not Python, right? It's similar, but it's different. It's kind of like a little bit alien looking. But we are ahead of ourselves. So let's go to look at the toml files first. pyproject.toml, we are more familiar with it. So here we are storing all this metadata for the library that so it's the product. So this is the library that you created. So this is storing the metadata about that library. So today we're just trying, so I just named it Python 101. I am very non-imaginative to name things. So, or you can put any name you like, but just be mindful that you may have to adopt the workshop accordingly. We are requiring 3.8 or above. Now 3.8 is also sunset. Maybe I should update that as well. But anyway, let's just keep it that way for now. So these are the things you will see on PyPI. So when you go to PyPI and look at a library, let's say you look at, let's say pandas. So you will see also like pandas will have all this information put in there. So this is just for the metadata, meta info. So this is basically is for Marturin, to tell Marturin about it. We have some buffer extension module, but this is quite standard. So don't worry, it should be generated for you. And also we are using this version of Marturin, so maybe you want to match this as well. If you're, if the file that generated for you is not using the same version, maybe you want to adopt it to our version because we try to have the same experience today together. Okay. So next, we look at something a little bit different. It's the cargo.toml. So cargo.toml, the function is very similar to your project.toml, but it's of course not for Python. It's for cargo. Cargo is the manager, and when you write Rust code, Cargo do everything for you. You can use Cargo to compile your code. You can use Cargo to format your code. You can use like Cargo is there for everything. So this file is basically giving Cargo some information about your project, your Rust project that you're writing today. So most of the thing, again, it's generated for you. You don't have to change it. But make sure again, like all these are matching to what we're using, especially Py03, the version of Py03 that we are using. If you are doing it like with the latest version, it won't be 21.2. So it will be a newer version. But again, like we're trying to keep it consistent for the workshop. So make sure this is matching to ours. Okay. So far, so good? Okay. So next step, let's look at what we're doing next. So we have already seen the file and stuff. Okay, so for the detail, again, I won't go too much into detail. For all this information, you can read it yourself and check it, like, all the reference and stuff afterwards. So difference between Python and Rust. Give me some example of the difference between Python and Rust.
One of them you cannot understand. Borrowing.
Borrowing, yeah, borrowing is which one? Rust, right? Yeah, Rust. Rust have something called borrowing, which doesn't exist in Python. Okay.
Also, the scope is different because in Python, the context manager are not binding with the variable.
Yeah, so that is a very deep concept, but in a nutshell, Python is an interpret language. So your Python code is most of the time, 99.9% of the time, it's not compiled. So what happened is that you need a Python program to run your Python code. So for example, you download CPython. So CPython itself is a program that runs your Python code. So that's how Python works. For Rust, we would compile it. So it's kind of like C, C++, all these also like are compiled. So you will have a compiler, which is Cargo, to compile Rust, and then it will generate a binary. Then it can run on like a compatible computer. You don't have to have a Rust program to run Rust code, okay, after compiling. So that's the huge difference. So of course, Rust have its quirk. It's have the borrowing, like lifetime, all this like kind of special things like that is like specific to Rust, which we would have a little bit of a look later, but we won't dive too deep into it. For Python, everything is an object, which is again like very different from Rust. So you can see also like how the two type of object met, like how to map from one to another. Also like is kind of not straightforward as well. So we'll have a look later in the workshop. So again, like there's so many details, but again, I won't dive into it. Just give you a overview of what's going on. So far, so good. Okay. So in Rust, we also like sometimes you heard me saying that. I'm just going to give you some like kind of explanation. So crate, we talk about crate in Rust a lot. So crate, you can think of it as another module in Python. So it's kind of in Python you import, let's say import datetime from datetime, import another module from another file or like from another module. In Rust there are different crates. So instead of import, you would use the keyword use. So you may see it already in the lib.rs. The use is a keyword that we would do. You can still use another crate without import, quote unquote importing, which is using the use. You just need to specify like where the crate is sitting. But so it's kind of like different from import. But again, like to make it simple, just think it as something working similarly. Okay. Another thing is macros. Macros is so if you have written in C or C++, macro is also something they have. You should be familiar with it. Basically, it's working very similarly to a function or a decorator. It takes some of your code as an input, and then it will give us other code. the difference, for example, like a decorator also take in your function, right? It will give another function as a output, so we'll run that function instead of the original function. But the difference between macro and decorator is that macro, you remember Rust is a compile language, right? So macro will work at the compiling time versus Python decorator. All this magic happen during runtime. So it's slightly different. Also, some macros look like a function. You would take some input, maybe some text or number. It will also give out something different. Again, it happened during compiling time, so it actually changes your code. So it takes some code inside and give out some code.
Is it like a C++ templating?
Very similar, yeah. Yeah, very similar. Template. I don't know if you also have macro in C++, right? Or you just call it templating?
We have just templating, but the compiler at compilation, they are run. So you can have O1 complexity on your code. It's instant during runtime. So all previewed. Yeah,
so I can't say for sure it works like 100% the same, but it sounds very similar. So macro, you mentioned that like one of the advantages is that after compiling, this is already done, so you don't have to do it every time you run the code. So that's why like macro is sometimes more desirable because it's faster. The thing has been already done once and it works forever. You don't have to put in effort to do it again. But function, if it happened during runtime, it's more dynamic because sometimes you can't predict what's going on until you're actually during runtime. But then the drawback is that function it will be at runtime, so it will take up some of the resources and time. That's macros. Again, like for simplicity's sake, for today, we'll just imagine they are function or decorator. We won't again, like you can look into the details afterwards, but for simplicity, we just imagine it's like that today. Another thing happened in Rust is called panic. Panic, whoa, so scary. No, so what panic is just it's kind of like what happened when we have an error in Python. So for example, in Python, when you have an exception, right? So something raises an error, raises an exception, the whole program will just stop. It can't continue. So it would just be terminated, got cleaned up. So it's just like everything stopped. In Rust, to do this, it's called panic. So panic means that it will just stop the program, and all the stacks or this like temporary thing got cleaned up, and then then you can look at the error message and then fix it before you run it again. So that's panic. But in Python, sometimes when we have something that an error, let's say you call a function, there may be a time that there will be an error. Sometimes you catch it, right? You will use try to see, during runtime, if you have an exception, then you do something to resolve it. So that's how Python do it. But in Rust, we are more organized. So we won't just like, oh, we catch if there's a panic or not. No, we won't do that. So when there's a panic, it would definitely stop it. You can't just like Python, just catch it and do something else. In Rust, what you would do is that most of the function or like most of the thing you write won't just cause a panic immediately, unless it's something very wrong that you want it to stop no matter what, then you panic. A lot of time, how you handle error is that you would return the error for whoever calling the function to handle the error. So that's how Rust works. You'll see the example later, which is easier to understand when you see actual code. But just to bear in mind that like in Python, something went wrong, raise an exception. Rust, most of the time, you would just you would handle the error, or if you don't want to handle it, you return it for the outside, the one who is calling the function to handle it. Okay, so that's error handling. Now, to start, we always start with like very beginning, right? Hello world kind of thing. So let's look at what we have been given. So it's kind of like a hello world thing. So look at lib.rs. So in Rust, when you are writing a library, you would call it lib.rs. So like in Python, like a lot of you can name it like, you know, whatever. Sometimes like the convention is to name it the same as the name of your module, but in Rust it's always lib.rs. It's the library, the one. You can have more than one file, but then like the one that is the top one, it will be lib.rs. So for this one, first of all, the first line, use PyO3 prelude. So this one, if you are using PyO3, right? So if you're writing Rust code for something else that is not PyO3 related, then it doesn't matter. Then you won't see this. But as long as you're using PyO3, again, 99.9% of the time, you don't have to think about anything. Just type this line, because what this does is that it will allow you to use all the PyO3 magic. For example, this function here, or like this like add function, wrap py function, all this stuff are in the prelude. So, you know, if you don't do this, then all these things will have problem, right? Okay. So that's why it's there. So don't touch it. if you don't know, then don't touch it. Okay. An example here is a function. So py function is a macro. The first macro that we see is this one. So if you look like the code here, so this is writing a function. So this is like, you know, in Python you have df and then like colon and then, you know. So this is the similar, is writing a function. This is just how Rust works. It uses, you know, instead of colon and then, you know, 4 spaces, it's just like have, you know, the curly bracket, kind of very similar to other programming languages. And also in Rust, you have to type everything. It's not an option. In Python, it's an option. You can type or not type things. In Rust, you have to type everything. So that's another difference. So you have to do it. So here, usize just means that it's the unsigned integer. Size means that they use the size, the default of your machine. So again, like you can dive into detail, but you will see like U32 or U64 or like this a lot. It just means it's an integer, unsigned integer. So it will give out, so this py function will give out a py result and then string here. So first of all, what is py result? So that's kind of related a little bit of how Rust is handling error. So you see all these functions, we have like OK at the end. So OK doesn't mean that it's returning. So in Rust, if you want to return something, you don't have to say return. If it's the last thing in this like curly bracket and without a semicolon, without the, you know, there's not semicolon here, then this will be returned. So what is returned is the whole thing that is called OK. So what is OK? So OK is a in Rust is a result object. So result object have 2 types. So there's OK and there's error. So as the name can tell, OK is not error. So it means everything is OK. There's no error. That's why it's return OK. And within OK usually is whatever you actually want to return. So for example here, this function actually return a string. So inside OK we have string. So like also why this is wrapped by a py result is because we have a result that got returned, but this one will actually become a Python function. So that's why it's py result. Py result is defined by PyO3. So just so you know. So yeah, this is actually a string. So you see a plus b dot to string will give you a string because, you know, we call to string, so we will have a string. This is kind of like again, like built-in function provided by Rust. I won't dive into the detail. You will see this a lot when you're writing Rust code. Okay. Next, we have another function, you know, function here, but this time we have a py module. So for today, because we're doing something very simple, just for demonstration, we only have one py module because we only build one module. Of course, you can build a multiple module for your Python library. You could do that, but it will be more complicated. So we are omitting all the complication today. We just like, you know, have one py module, and then is you know, we just compile every 101. And so again, like this looks very complicated, but don't worry, just copy it. Don't change anything. What is bound? What is this? Again, like this, most of the time you don't have to change it. If you use a different version of Py03, this may differ a little bit. That's why we try to use the same version of Py03. But again, like let's say if you finish the workshop, you want to use a newer version of Py03. Oh, what should I do? Go to the documentation, just copy from the documentation, because most of the time you don't have to customize this. So just don't change anything. And then this time, this one will give out a Pi result with nothing inside. Because when everything works, then we don't need to return anything. So okay, nothing inside as well. So we don't return anything. We just need to return an empty OK object saying that like everything is okay. So M is actually our module. So M, and then we dot F add function. So we have this wrap Pi function here. So this looks like a function, right? But no, it's not a function. It's actually a macro. The differentiation between a function and a macro is that it ended with an exclamation mark at the end of the name. So you can't name a function that ended with an exclamation mark. That's for macro. So, but this, so like this is a different type of macro than this one, right? So this one looks like a decorator. This one looks like a function. So there's two different type of macro. So this is another type of macro. But again, we are not teaching you how to write Rust macros, so I won't dive into the detail. Just bear in mind that it acts like a function, but it's not a function, it's a macro. But you can, most of the time, you can just use it like a function, okay? So what this macro does is that it will take your function that you have written, your Pi function that you've written here, and then the module M, and then it will wrap it, make it ready to use by Python, and then it would just wrap it in the module, okay? Put it in the module. So the last mystery is this two question mark. What is this doing here? Why there's a question mark here? So remember, I said that most of the time when there's how Rust handle error is either return, so it will return a result object, which is either an OK or an error, right? So for this, each one of them, right? For this like wrap function, this is a macro, but it works like a function. So it will also give you a OK or an error as the result of this, okay? So there is also like this add function also will do the same thing. It's also either OK or result. So a lot of times when we write Rust code, because what you get back is something that you can't directly use, right? Like it's not a string, or is it not a number that you can directly use? It's a result object. You have to unwrap it. You have to, you know, maybe, oh, if it's an error, do this. If it's not an error, do this. So, and then, you know, whoever started writing Rust realized that a lot of times we just pass, like if there's an error, we just pass it outside for whoever is calling it to handle it. I won't handle it myself. I would just pass it on. And if it's okay, then I would pass the result, whatever inside okay. For example, with this string, I would just pass it as a like just pass it on, right? We just want to return it. So they created this shorthand question mark. It's saying that if it's an error, so if it's an error, you don't have to run this. You don't have to go outside. You're just like, okay, just stop, give this error, like pass it outside, and then someone will handle it. If it's okay, then unwrap the okay and then put it into like the add function, and then add function will also give you something. If it's okay, then it will just, everything will be okay, then it will be returned okay. Okay. If it's an error, it will just stop. Like for example, I have any error here. This okay won't work because it will just stop there. And the error will be passed out directly. Okay. So a little bit complicated. Or are you getting? Did I lost you already? Or you're okay following? Yeah. Okay. So this is how Rust works. So it's a bit, you know, uncomfortable at the beginning, but once you get used to it, then it's, you know, it's straightforward. So we have analyzed the code, so we're good. Now let's try to see how Matrin works. So like I said before, Matrin is the very important tool that we're using. Without Matrin, we can't do whatever we want to do today. So let's look at what Marturin does. So, well, what Marturin can do for you, let's say. So here, can you see, or is it big enough? Big enough? Yes? Okay. So if you type Marturin help, you will see. So all of these commands that you can use. So it including like, publish the package to PyPI, build a package, so you can use it like locally and other stuff. But today we will just mainly use this one, develop. So develop is, is for development. So what it does is that it will compile your code, so they will quickly build a module, not optimized though, like because in the Rust compiler there's two ways to compile your Rust library. It's either just compile it so it works without the error, so it works, or compile and then optimize it. So usually if you compile and optimize, it takes longer to compile. You will only do it when you're ready to publish it. Then you would optimize it because it takes a longer time for you to compile. While doing development, like you want the cycle to be faster, right? You change a little bit, like there's a typo and then compile it again. So it will just do the bare minimum. It will optimize for you. So if you use Marturin develop, it would kind of go into that mode. And also it will install as a library in your local environment. So you can test it out with, you can write a Python code to test it out. So that's what we'll do today. So after this, we can try it out already because we already have some code here, even though this is a default code. So let's try to build the library and see like what we can do with it. Okay, Marturin develop. So, it should be done, right? Nope. You're still building. Okay. Yes.
Is there something like you install where it would recompile essentially?
Yeah, it will recompile it, and then actually it's editable. So like if you do pip list, here you will see, I install locally here.
Is that result of Marturin develop?
Yeah, this is, Marturin develop will install it locally. So you will see this. So before, if I type it before, then this won't show up, actually. I should have done it, but like, yeah, if you try it again at home, you can try to see pip list. It's not with, like, you won't see this before you run Marturin develop for the first time. So, and also, like, for example, this is your version number. You can try to, like, maybe go to your PyProject.toml, change the version number, and then again, like, this will change. Yeah. So, any more questions so far?
So this package will be visible for the virtual environment, even outside of the Marturin product.
So for me, because I use PyEnv, so it's installed in this PyOV environment, which I created with PyVirtualEnv. So as long as you're in that environment, you would have access to it. Yeah. Yeah. So any more questions? No. Okay. So yeah, you see it's installed, and you can see it in the pip list. You can see it's installed as editable because like again, like it's in development mode, so you could usually you just change it by Marturin develop again. So technically, I don't know if it will install it again or something, but again, like I think it's maybe like if you want to manually change it, like the Python, but don't mess with it. We just do Marturin develop today. Okay. So yeah, okay, right now we will do we have target here? Maybe I've hide it already. Okay. So next we want to try writing our own. Oh no, before that we want to try if it works first. because like, okay, now we have generated this Python library, but does it work, right? If it doesn't work, then it's, there's no point continuing today's workshop because this doesn't work. So let's create a Python script to try it out. So I normally, I will save it outside, try.py. I will just call it whatever. I go try.py. And then now it's your time to write some code, because we are writing Python code now. So I don't need to hold your hand, assuming that you're a Python expert. Can you write some code to try our new library? So remember this PyOverlay 101, we should have a substring function, right? So try using it and see if it works like what you expected. So just like, put in two numbers to integer, and then to see if give you back the correct answer, which is a string. You can also check the type. So now is the time to write some code. I'll give you a few minutes to write this code to test it out yourself. So I hope you have also written some code. It doesn't need to be the same as me. I'm just like cheating because I just copied the one I've written before. And now if we run Python, so yep, so it works as what I'm expecting, because I add 1 and 2, so it give up 3, and then the type is string, str, string. So it works. Does your work? Yes. Okay, good. So now we have built a Python library written in Rust. Cool. But that's not our Rust code. That's just given to us by Materine. So let's write our own code. So now we want to write a function called say hello. So say hello will take in a string, and then it will give back a string, just saying like, hello, how are you today? So yep. So you can try writing it yourself, or you can cheat by copying the what we had in the file, right? So this one here, because we are using the type string, so this is how you say, like, you have to have capital S here. There are reasons why, but again, like, it's too complicated. I won't dive into the detail. But if you want to, take a string in Rust, one of the way to use this string with capital S. And then, so this is kind of like the old formatting we do in Python. Before we have f string, this is how we, like, very similar to how we format our string. But in Rust, it's using a format macro. So, so this is how we do it. So again, we would wrap it in OK because we return a Py result. This is how we do it. So now, if we save this and try everything again, okay. So try Materine develop, okay. It says that it has been installed, and then we go to try.py, right? So if now I print, so maybe I delete the old one, I don't need this. Yes, you have already stepped ahead. I'm trying to show you what happened if you don't. So yeah, let's assume that you haven't heard that. So, okay, now we print, let's say, oh, I will print out, what's the say hello, P1 dot say hello, right? Yeah, P1 dot say, oh, I need to use this. Oh, or I can just print it out without F string. Let's do this. Say hello, and then let's say John. Okay. So if we run this, oh, sorry, I didn't use the right command, do I? Oh yeah. So if I now try to run it, then it will say like, oh, we don't have the function say hello. Wait a second, we have just built it. Well, why we don't have say hello? Actually, you can already see it from the from the error build message here, is because there's a dead code warning, meaning that you forgot to add it to your module. So what does it mean? Remember, we have to add the summer string in the module so it can be used. So now, even when you compile it, Rust, the compiler of Rust will tell you, hey, you have created this say hello, but you haven't used it. So that's already a red flag. So you should fix it by also adding it to our module. This one just say hello, so you just change the name. Okay. So now if we do everything again, right? So, okay, we do maturing develop, and then we would run the try again. Yeah, so now it would say that like, hello John, how are you today? So it works. So remember always add it to the module. I keep forgetting it as well. Like, that's why looking at the compiler output is sometimes very, very helpful, because then you know that, oh, I forgot, But it's fine. We are just testing things out now. So you will forget many, many times, and it's okay. So, right. So far, so good. Any questions? Yes? Sorry, I can't hear you. Yeah. There is actually a FFI in PyO3. If you go to the source code of PyO3, actually there's a PyO3 FFI. Like so PyO3 is trying to. It's not there yet, but like we are trying to have its own version of FFI of C Python. But there are some still missing. Like yeah, but it has its own. But that's too deep of a topic. Today's beginners class, so yeah, we can talk about that later. Yeah. But that's in the source code. If you're curious, you can look at the PyO3 source code. So now, after say hello, we want to welcome someone to also the conference as well, right? So let's change our code a little bit. We'll just say hello and welcome to the conference. Okay, so let's copy this and change it up a little bit. Okay. So now I'll say hello to whoever and then welcome to the name of our conference. So this time, if I do this maturing develop again, right? And then I go to my code, I will say hello, John, but we also need, let's say, Pycon APAC. Okay. So now if we run this again, you say, hello, John, welcome to Pycon APAC. Good. But what if, like, I forgot to put Pycon APAC? What happened? Then, of course, like, we have an error because we're missing one argument, right? So in Python, how you could fix that is that maybe you can add a default. Maybe the default is Pycon APAC. So, if most of the time it's just for Pycon APAC, then you don't have to type Pycon APAC every single time. But how can we do that if we are writing in Rust here? Can I just equals to Pycon APAC? Well, I guess you already guessed that it won't work like that because this is not Python, so you can't do this. So what should you do? So in PyO3, actually, it gives you a way to do it. Is to use this magic here. So this is another macro here. Let me highlight it. So this is another macro here that, so there are a lot of macro provided by PyO3 that can work magic. So this is one of it. So what it does, it will add a function signature to your Python function. So, okay, it's quite useful. I can label it as name, but I think, in my opinion, the most useful thing is that you can set a default to your variable. So, for example, the conf, here the default is just the conference, okay, because we don't know which conference. So we can just set it here like this. Notice that we also need to use this toString thing, which is, you may ask oh, but this is already a string. Why do you have to use toString? Because in Rust there are multiple string type. So again, this is another rabbit hole because string type in Rust is super weird, but just follow it for now. That just know that there are different string type in Rust, and then if I want it to work, so this I need to use to change it to string. Okay. So now if I update it like this, adding this magic here. Okay. So okay, of course, don't do this Python thing because it won't work. And then add this here. So now if I go back to my terminal and do margarine. Oh, sorry. Type the wrong thing. Okay. 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 Let's clear it up a bit. I'm very confused right now. Okay. Margarine develop. Okay. So after develop, we do run the code again. So now, instead of an error message, I can call in the default, the conference. So it works. So this is how you can also have default when you're using PyO3. So even if you're writing in Rust, the Python way doesn't work in Rust, you can get around by using some magic provided by PyO3. So I think there is a way of I think the text signature may or may not, it depends, because what this does, there's a thing called type signature here. So we are using signature. There's also the text signature here. So what it does is that if you inspect the function, for example, if you go to your Python script and inspect the say hello function, you will see that there's a new attribute added to it. So if your type hint, your type hint thing will look at that text signature thing and type hint for you, then it will work. But I haven't tested myself, so maybe you have to do some testing yourself. But this is what happened. I can only tell you what PyO3 does. It's just it will create that text signature attribute. So some people report to me and say oh, it doesn't work. It's oh, maybe your type checker doesn't check that thing, so that's why it doesn't work. So yeah. Maybe, yeah. I am not sure. You can actually go and there's actually a Discord server, so maybe you can talk to the maintainer there and see if they have already a plan to implement it or already have something similar that you can use. But I don't know the detail. Yeah. So far so good. Exercise 1. Now we can already start writing our own, library. So okay, I will just move on if nobody say, hey, wait a second, or question. No question. Okay. Okay. What function?
Variable arguments.
There's actually, yeah, like you can also have you mean yeah, those things. I think there's a way to do it for sure, but I didn't include it here. You need to go to the user guide to see the example from their documentation. Yeah, there's a way to do it, but I didn't include it here. Yeah. So let's do error handling and file I/O, which is fun. Okay. So in Rust, if we want to do some file I/O, so this is normally what you do. If you want to read a file, then you have this read that you need to put in, and then the file. So you need to use both of them. So we have to put that in our code. So let's put it here. Okay. Next, we will create a new function that will open a file, and then it will just read the file and do all this thing. So let's look at it like decipher it a little bit. So because we have some new syntax that we're encountering. So what is this like let mu thing here? So in Rust, if you declare a new variable, you can't just like in Python, right? In Python, you just assign something to file, and then Python will be like, oh, I haven't seen file yet. So you are creating a new variable. So they would just, just do it for you. But in Rust, everything, so it needs to be a more like explicit. So you have to tell Rust that, okay, now I'm creating a new variable. So that's why you need to use let. So let is doing that, but what about mu? What is mu doing? Mu means that when Rust create this variable, it will be marked as mutable, which is like you can change the content of it. If it's not mu, then later if you reassign something to file, then again it will be an error. Oh, and then panic or whatever. It's like it's bad. So, actually it won't be panic because like the compiler will already tell you no, you can't do that. So you can't compile your file, basically. So, so yeah, like if you want to create a variable that's mutable, you have to use let mu. So after that, we'll just use the open in file. So remember, we already have files, so we can use it here like this. And then what is expect? So the name is a bit counterintuitive, I would say, because inside expect, you will have an error message. So what this does, it means that whenever something goes wrong here, when you open a file, something goes wrong. I don't know what happened. Maybe the file doesn't exist. Maybe, you don't have the permission to open a file, whatever. There's an error. Then it will panic, stop, and then give out this error message to the terminal, back to the terminal. Okay. So we will see what coming out next. Yeah, we'll see what happens. Okay. So the rest is, just okay. I create a new string, so their content, and then I can use file.read to string to change the content into whatever the content from the file. So basically, what it does is that because content is mutable, whatever the content that's got read will get put into this contents. Okay. So, why is there an mu here? So this is again like some Rust thing going on here. Rust, when you pass something inside, so in Python it doesn't care, right? In Python, if you pass a integer, then it just works as an integer. There's like you don't care about the nuance of like, oh, is it the same integer or do you make a copy of the integer? Python will just take care of it for you, so you don't have to think too much about it. But in Rust, everything you have to take responsibility. So here, what it does is that because we create this like new string that is called content that is mutable, and we want to let this read to string function to mutate it, to put the content into it, then we have to use nmu. N means that it's the reference. So these contents that got passed in, it won't get copied. It's the same as this content, right? It won't be a new string. It's the same string as this one. And it's mutable, so we can change it. We can put things in it. So that's why it's mute. There are some restrictions. That's why the borrowing rule of Rust come in. There are some restrictions of when you can use mu, when you have to use n, you can't use mu, and all these crazy things. Again, today we don't have time to cover it. If you want to learn more, you have to read the Rust book, which the link is at the end of the reference. Okay. So that's what we do. And then, okay, so if, we have the name. So again, name is a string. So we won't make a copy of it. So we'll use n name. But this time we won't change it. We just want to check, So if it's inside, if it has the name, then we'll say, oh, you're registered, because we're reading the register file. So see if this person is registered, can come into the conference. If not, we'll say, sorry, you're not in our list, our guest list. You haven't bought a ticket. You can't come to our conference. Okay. So it's not quite complicated, but let's see what's going on when we put this in, right? So let's put it in here. And remember, we have to add the module. So add it to the module. So it's check correct. So we just copy this. It's so simple, but if you forgot, nothing will work. Okay. Right, so far so good. Okay, so our material develop. And then let's try it out, shall we? Yeah, let's go to our Python script and try it out.
Maybe no folks were okay to not have a semicolon at the end.
Okay, cannot have a semicolon at the end. It's big.
It's a return value, so it's special.
Yeah, like did you edit like here? It's because it's expecting you to return a pi result, and if you do semicolon, it means that it hasn't have a return, so it doesn't match what it's expecting. So
like in a SQL, when the semicolons are pressed beyond.
Yeah, semicolon means that if you put a semicolon here, it won't return. So for example, if you add a semicolon here, then it won't return the OK. It's just there's an OK object floating around, but it, so it doesn't got return. But then remember, we are expecting a pi result. So there's nothing. There's not a OK. It's expecting an OK, so I can turn into pi result, but it doesn't. So then, but that's why there was an error in the compilation. Okay, we have already compiled a new one, and we have added this. So let's try it out. So again, I will take this away. So what's going on if we try this, right? Okay. So this is what we want to see, right? Okay, let's put it up a little bit so we can see. We can't read the file because we don't have the file. What error do we get? Is it a Python exception? Is it a Python exception that we get?
No,
Right, yeah. So actually, yes, it's a Python exception, but this is a exception that PyOfree created, because remember, we write in Rust code when we panic doesn't exist in Python. So what PyOfree does is that see that, oh, if there's a chance that you would create a panic in Python, it would become a panic exception. So PyOfree created this panic exception to handle this, but PyOfree doesn't know what kind of exception it is, right? Is it a value exception? Is it a file not found exception? It doesn't know. It just see the panic. So that's why it creates such a, strange exception called panic exception. So because it fit the bills because of the panic, right?
we cannot label it.
So yes, what if I want it to be, in this case, it should be a file not found, right? If you do it in Python, it's a file not found. You probably don't want to put, like, show this to your user because they may not know you're using Python, you're writing the library in Rust. They are expecting a file not found exception. They may try to catch that in their Python code. So what we can do is to work our magic. So here, what we can do is to use a file not found exception provided by Python. So, but this one is not in the prelude, so you have to, write this line here. So we go back to the top. We just put it here. Again, don't worry too much about formatting. We can do the formatting at the end. So, okay, so I will stop for a little bit so you can catch up. But again, like you can copy everything from the GitHub because I don't think we have time to run over 7 exercises today. That would take 3 hours. Yeah. So after that, we also have to do something a little bit different. So instead of just flowing a panic, we would have to have more hand holding to the error handling here, because we can't catch the panic exception and do something, right? That's Python. If you want to do it in Rust, you have to do something like this. Use the match. So let's look at what we're gonna do next. So remember, in the previous code, when we have the file open, we will have .expect, right? So we throw an exception if things don't work. We don't take we don't care. It's just like if it doesn't work, just stop. Now, if it doesn't work, we don't want it to stop immediately. We want to check what's going on. So what happened is that we would just store this file open, because remember, open will give a result object, right? Before, when we use .expect, it's just automatically handle the result object for you. But now, this file result will actually catch the result object. So there's 2 things that could happen. So that's why we use match. So if you're using Python also have match, so maybe you are not too, you're also familiar with it. So file result can either be okay. So if it works, then it could be okay. It's not always error, right? Or it could be an error, right? So there's like 2 branches. It's either okay or error. So if it's okay, what would be inside okay? So what's inside okay is actually what we are getting last time, right? So so there will be the file. So we will get back the file. Last time expect just automatically open it for you. But now we open it ourselves. So we would take the mule file within OK and then use it here. We would just use it because we have already opened it, and we put here and use it. So this is the same as what we did before. We create a mule content, and then so this is all the same, right? So yeah, all of these are just like similar to what we did before. So I won't explain it. If it's an error here, then we would pass what we will return, right? So if we have an error, we don't care what Rust error give me for now. You could technically you can check like, oh, is it a file not found error, or is it like a the permission is not granted or whatever. You can do more, but right now we just assume it's file not found for simplicity. So whenever there's an error, we just assume it's file not found. So we will return a file not found error with a error message file not exist. Okay. Then if this match is an error, it would just return this error. So for Python to handle it. Okay. So now let's see what happens if we do it this way. So go back to here, and then we update our function. Okay, save, and then do muttering again. And then, okay, let's try again to see what happened. Okay, what's different this time? Yep, this time is a file not found error. So if this time in your Python script, let's go back to the Python script. If you are doing the try, you know, and then like, you know, how you do it in Python and then except, then you can put like file not found error, like, you know, file not found error. This will work. Before, this won't work, right? It would just, you know, oh, there's an error, that's not file not found error. It would go to whatever the other thing. Now you can catch it this way. And this is what the user expect, right? If there's not found, there's a found error. It's not a panic error. And remember, we also have the opportunity to catch different type of error as well. If you don't do this way, you do it the old way, everything will be a panic error. We don't know what's happening. But this, you can be like, this is error, and then you can check. You know, you can be like if error, whatever, like do something that you can check depending on this error. You can have different Python error return, different error message. You can do more sophisticated things. Okay, so this is very good.
This error will be only the one on the result of the opening of the file, or also on the inside of the file. We have to create this kind of structure for every line on code that is dangerous.
Yes. That's why the question mark is very good, because question mark means that like I'm not handling it.
So I can put the question mark inside all the OK section so that it will be collected.
Yeah, for example, this question mark. So it won't be down. It won't go to this error. It will go to actually upper. Yeah. So yeah, so like this is just like going upper to like, you know, when you put. So this will also give back a strange error, like if it's read to string, like, you know, yeah.
The full set of errors that function return.
What do you mean by that? Like, it's
basically have 4 lines of question marks. Does it know like 4 or 15 different errors that can happen?
So whenever it hit the first question mark, whatever error it has, compilation, it doesn't. It would just become a command that pass it on, so we don't actually know what error it is. It just pass it without checking with. It's just Py result, like all result. Like if it's just Rust code, it's just result. So it's always a result type. So if it's error, it will just pass as an error. So it passes the same. So it's also passing the result type. So type is always a result.
So to be really clean, we should, for every function that you want to export to Python, you should create 2 Rust functions. One that calls that do the matches of all the errors, and that inside call the other function that send with the question mark.
Yeah, so most of the time you will see this a lot, like OK and error, because there's, you know, OK and then a happy path and a sad path. So a lot of times you will have this. So but also a lot of time you just do the question mark. You don't care and do the question mark. So this one, the question mark probably would just, let's imagine like it would just pass out as one of the, so this will return an error.
Okay.
So but because we only this error branch will pass this error, so this one will be another like maybe panic error or whatever. You can try it out yourself to see what error PyOV decided to give you. Yeah. Yeah.
And we don't have to check if something is empty or we don't care.
What do you mean by something is empty?
If the file is empty, it's not a problem.
For here, yeah, for this code specifically, because the content will be an empty string, and empty string won't contain any name, so it would just go to this one as a result. But of course, like you can also add another condition to check if it's empty, then do something else. Like that's your design. Yeah, we are not doing it today because we just want to show you the basic. But you can make it very sophisticated if you want. Yeah. Okay. Cool. So that's how you can handle the error in a more user-friendly way. So the rest to do here in this exercise is to like, oh, what if we have the text, then it should not be going down the error path. It should be the happy path. You can check if it works, as expected. You can do it yourself because I have done it before, so I won't do it again. I just trust myself, but feel free to try it yourself and don't trust me, okay? So, yeah, because we don't have a lot of time in this workshop, I will just move on ahead and then see how far we can go. So, next, exercise 3. So this is almost a halfway point. Usually 1.5 hour workshop, we would finish exercise 3 and the rest you have to do it at home. So exercise 3 is we are experimenting different conversion between Rust and Python. So for example here, Rust has like different string type, like I said before. So that's the type that we choose is like, remember the string with the capital S. So it's actually, if you just type like conference in double quotation mark, it's not the string type that is the string with the capital S. So that's why we need to call to string to make it to that specific string type to pass. I think that's the default used by Python. Let me see if I'm correct or not. So this is a table. The link, again, you can find it in the README file. Yeah, you see in Python, string type. In Rust, so the string is the most obvious one, but there are actually different string types that Python will also convert as a Python string. So, for example, this is the double quotation string. Technically, you don't have to use toString if it is, but if you define this as, an str, then you don't need to use toString. But then like, yeah, but then it would be very weird, like, actually, will it work? I haven't tried it. Now I want to try if it works. So, yeah, like, because the different string type in Rust. So let me see if it works. Sorry, I'm going off script here. Yeah, I'm going a bit off script because I have a crazy idea. So let's see if this works. Okay, let's do this. Yep, it works. So it's just that they need to match us within itself here. So yeah, if you don't want to use the string, you just change the string type to the correct string type in Rust. So both this string with a capital S and this and stir in Rust, both will be Python strings. So Python doesn't care, and Python is doing the conversion for you automatically. So other thing that Python can convert it to you automatically, for example, integer. Remember in Rust, right? We have all these like weird like usize, U32, all these different kind of integer type. Again, like Python will automatically convert it to int in Python for you. Okay. So in this case, then like as long as it matches everything in Rust, then in Python it's fine. Okay. Another more strange thing is that like list, in Rust we don't have list. What do we use? We use back. So more detail about this back type in Rust is in the Rust book. I won't go into the detail. It's working very similar to list. That's why this is the mapping. For dictionary, we are using hash map.
The Rust side modifies it and you expect the function to give value.
What do you mean? Like, do you mean like this list or?
Yeah, let's say you declare, so where you declare the default for the argument as, I guess, actually I don't know what it should be.
Actually, you have to. So let's say like I have this is like a U size, okay? So it will become an int in Python. Actually, in Python, on the Python side of things, you don't know its U size in Rust. Like let's say the user doesn't look at this. Yeah, it will just see that it's expecting int. So like let's say you do myPy or do typing, like if it's not an int, then it will complain because Py already changed into int in this library here for you. Oh yeah, like those edge cases. I don't know. You have to try.
I think there are the operators of the generics in Rust, so we can set up something that sounds like an integer, and we don't care what's the current type. It would be more like in Python. If I remember something.
Technically you can just create a Python object from scratch, but again, like that's you know, I like why like if you really need to, you can actually create a Python object from scratch. Like there's a thing in Py that lets you create like a Python object. There's the PyAny.
So how to deal with a single object if they are all numbers, but maybe some is
you want a mixed type.
Big,
yeah, for mixed type, it can't be easily done. Because in Rust you have to have the same size, right? You can't have a list. You can have a vec that have like, you know, a one is U32 and the other one is I128, or mix in some float in it. You can't do that way because in Rust the vec needs to be the same type. You can do some like magic by creating a super complex type that maybe you build your own like array of like having your own pointer and all this thing. But you know, I think that's very complicated. If you really need that flexibility, you can, but again, like I think most of the time people will just like, you know, if you don't know, maybe you just use the biggest one if you don't care about like wasting some resources, you know. For general use is enough, but like for a special case you need to be really flexible for whatever reason, then you have to build something more complicated than just a vec. Yeah, or maybe a vec with a, you know, later you see there's like, you know, this like pointer type, smart pointer, or like a box, or maybe you have an array of pointer and then they each point to a different object. But yeah, that's going to a very, you know, complicated situation. Then we just, you know, ignore for now for simplicity's sake. Yeah. Okay, so this is something you can always come back to have a reference to if you're like not sure. So yeah, like this is what you can do. So now the rest of the workshop is just like, you know, try it yourself. Try to create different types. You know, don't create something super complicated. Just look at the list and then maybe try a different type. Try some vec, you know, to create a list, or try using the heat map to create some dictionary. So yeah, that's the rest of the exercise. Just like try it out yourself. Different types of things. See if it works. And then at this point, usually people have lots of questions. Oh, what about a coroutine? What about I want a, you know, a create a Python function from, you know, a class, a Python class, you know, and all this. So all of them, I hope, like if you continue the exercise, it will answer some of your questions. And feel free to try it like today, you know, when you have time, maybe back to the hotel or something. Like you can try it yourself. I will be here still like tomorrow and Sunday. Also, I can be contacted online. And also there's like a Pyo free online community on Discord. You can also go there and ask questions. So yeah, so because there's so much to learn, I can't cover everything. And I'm also thinking about having an advanced workshop, a continuation of this one. You know, next year I'm gonna build that. So hopefully if I'm come back to Pycon APAC, I can present that. But yeah, there's so much to learn. So in this workshop, there's like 7 exercises here. So it will cover you, like the rest will be custom Python classes. it will be how to write an iterator, all these things. That's quite, create iterator, like all this fun stuff that you could do. Also, the smart pointers, we'll touch some smart pointers at the end as well. So yeah, a class decorator, and then we'll use some, yeah. So also there's like, if you want to learn more Rust, there's a lot of like a very good resources there. I highly recommend reading the Rust book. It explains a lot of Rust concept there for you. But for more practical stuff, Rust by example is very good. Like a lot of time I don't know what this, this function in standard libraries doing, that I can look it up by Rust by example, this stuff. Yeah. So this is yours now. You can take it home. Who doesn't have the link? Who want to have to look at the link again? I can show you the link again. Yep. So the link is here. Take this home. You can continue learning. Again, like feel free to ask questions while you see me, or you can message me. I think, yeah, I think we can slowly, close this session and wrap it up. If you still have questions, this is your last chance to ask before we leave the room. Any more questions? Yes? A compiler for other so C Python is using C, right? So compared to C, Rust is quite a young language, and I don't know if like, are you asking like whether there are like different version of like Python interpreter that compile to like that make it into other compile language, or is it like? Right. So PyOV only work for Rust. So yeah, like, but who knows? Maybe in the future someone will develop. But yeah, like if you are curious, oh, why PyOV can do all this thing, like that involve like looking into what C Python is doing and then mimicking and all this stuff. But again, like that's very advanced. I don't know too much. Like I don't know enough to teach you about that. So, but I can point you to where you can dive into it if you're interested. Yeah. Oh, PyO3 is actually O3 is oxidized, right? When things got oxidized, iron FeO3. No, oxidized iron is rust. So FeO3 is rust. So they changed to PyO3. Yeah. 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 So. Mm-hmm.
If I have some asynchronous code in Python using async IO.
Yeah, that's what I'm gonna do in my advanced version. So Rust gives you an opportunity to do not just async but parallel, because you can technically assign things to different threads. So you can do parallel using different cores with Rust. But async only, as far as I know, only do concurrency. So it's two different async. So async actually have like, there's two different types. So there's parallel and there's also concurrent. So async in Python is doing concurrency, so it's different. But how to mix and match and use both of them with PyO3, that's another topic that we can maybe cover in the advanced workshop if I make it and present it again next year. Yeah. But if you already want to dive into it, you can go to their user guide. There's a section about async, Python async. 5 minutes left. We should wrap up. Any more questions? Last question. No? Okay, you first. Yeah, so that's the difference between compile language and something like Python, like interpret, is that Python is quick to develop but slow to run. Rust, after you develop it, you compile it, like you compile it also with optimize, so it takes some time for you to compile it. But after you compile it, it's a binary, it's very fast. So for example, have you used rough or have you used UV? It's very fast. Part of it is because it's written in Rust. The developer already done the heavy work, which is compiling it for you, and then when you use it, it's fast. Yeah, that's the speed. Also, some people prefer like, oh, because like some people prefer like Rust, but again, like yeah, it's personal preference. Yes. Mm-hmm.
Let's complete a new language. So maybe we tend to think like Python. So for example, when I want to get a future module, which is depend on Python, let's say pandas. Should I write pandas in Rust myself, or do I need to check the alternative of polars? Yes. Polars.
Yeah. So how I look at it is that like Python, like Rust won't replace Python. Like in my opinion, Python has an advantage. Like for example, for people who are data scientists, they want to create some look at the data and do some analysis. Python is very good for them because they don't have to think about like all these engineering things so much. They can just quickly do the job that they want to do. But imagine something like Polars. The engineers already optimize it using Rust for them, right? So it's two different group of people taking advantage of two different languages. Today I'm teaching you, so you have a choice that you want. If you want to be bilingual, you want to speak more than one language, you speak like Indonesian, right, and then English. So it's your choice. You can also, after today's workshop, say, oh, Rust is really not for me. I want to stay in Python for now. It's also okay. It's okay, right? But if you are interested, you say, oh, Rust is actually quite fun, and you don't mind like struggle a little bit. Sometimes you mix up and But from my opinion, it doesn't mix up so much because you bring switch. I'm also bilingual, and so like when I speak English, I won't mix in my Cantonese, my mother tongue, and you will adopt. Humans are very good at adopting. So, yeah, if you want to learn a new language, learn a new language. Okay. I think that's it. So thank you very much. I will see you tomorrow, maybe.
Thank you.
Yeah. Oh yeah, yes, sure.
And I take a photo.
Okay.
Picture. Ya. Pakai HP-nya siapa? Pakai itu, pakai kamera itu boleh.